This is our video games by me, Tyler McNeil.
I'm Peyton Lapointe.
I'm Elijah Marshall.
This is our introduction screen. We all have a love of video games and wanted to make something useful and accessible, like a database to manage and search for the best rated games based on genre, availability, and price. We want to know what developer has made the game and what rating it has. Knowing the games in our past, we wanted to be able to search through the query in our database to help us pick games for our future that have similar attributes. Putting together this project will not only help us deepen our understanding of database management, but also provide a practical tool that can be expected for use in game stores, review websites, or personal game collection. I created the ERD diagram, helped with the creation of database, creation of presentation, and worked on the final report. Elijah was the main contributor to creating the database, helped create the SQL queries and interaction of data, and worked on the final report, while Peyton was the main contributor to data creation and finding, helped with SQL queries and creating the database. And he also worked on the final report and this video like everyone else. This is our ERD design. First, we started out the table of developers. It has multiple attributes: the name, the country, the founding year, and the developer ID. The developer ID is the primary key that is within developers, and the transition between developers into genre is developed many to one, because there are many developers to one genre. And then for genre, the table, it has two attributes: a type attribute and the genre ID. The genre ID is the primary attribute to the table, while the type attribute is the foreign key. Actually, the genre ID is the foreign key. And then for categories, one to many, there can be many games for one genre. It categorizes them. And game has 5 attributes. So game ID is the primary attribute, and it is also one of the attributes that is going to be our foreign key for this. And combined with the rating, release date, and pricing and name as being the other attributes. And is a delivery of one to many, so one game can go to many regions. And each region table has the 3 columns are attributes: sales per region, name, and sales amount. Though it, of course, also has ID, it is the region sales ID. All right, next page.
So I did a lot of the logic behind how we'd organize these tables. It mostly the main scheme is there. It's got the developers, game, genre, and sales, as you saw in the last diagram. We actually went through quite a few variations of this. As you can even see on our project check-in, the ERD diagram we use there is not the same as what we have now. When we started actually putting these into practice, we realized that there was some issues with how it was originally structured. Primarily, it was having name be the primary key in the different tables. We ran into some issues with that, so we started using IDs instead. For the most part, the IDs match up, with the exception of genre, which have different IDs. Uh, Genre is the table that's least complicated. It's effectively just storage for the different types of genre. Um, Games where the majority of the action happens here. It's got the everything that you need to connect to all the other tables. As you can see, with the foreign keys kept within, in the genre ID and the developer ID. So we use that to connect to the developer on some queries, and I believe genre and sales at different points. Um, Sales contains different region sales, as in like continental sales, North America, Europe, and Japan, as well as others, and the global sales. And it also has an ID that matches the game ID, hence why there's a foreign key for that there. So we have our creation deletion functions. Uh, you know, you can insert different games into the games table and or the other tables that we primarily use for games, since that's necessary for the other ones. Delete is just the opposite. It deletes an entry from any of the tables, specifically games here in this instance. Uh, this was deleting Halo 3 and then inserting it back in for on the instances you can see here. Read and update those. Well, they read like Halo, seeing what Halo 3, reading Halo 3 and showing you the name, rating, release date, pricing, ID, and well, all types of ID. Update lets you change a element or an attribute of an entry. Here, changing Halo 3's pricing from the $40 to down to $9.99.
Okay, my name's Elijah Marshall. I made a lot of the complex queries beyond the read and update functions that would allow like multiple, like you could draw info from multiple tables. The first one we started with is the genre search, and like Peyton said, the genre table didn't have much information, just was used as a storage to store all the different genre types. And this one focuses on like specific games that you would maybe want to look up, like Elden Ring, Minecraft, or any others, and pulls out their genre. It's helpful for recommendations or filtering a game catalog. And if we ever wanted to let users browse by genre, this would be one of the first steps. So you see in this one here, we look up the most popular game, and it's Elden Ring, and it's a fighting platform game, which is really the main characteristic of that game. You're always fighting either weapon combat or a brawler, so that's its main category. The second one is a studios and their global sales result function. This one totals up the global sales from each developer. It joins the sales, game, and developer tables and groups everything by developer name. The result gives us a leaderboard of who's making the most money globally. It's especially useful for identifying the most commercially successful studios. And we can always modify it to look at the regional trends too, or we could specify it by the country or region instead of just looking up the total global sales if we wanted. And can you go down to studio? Oh, sorry. Studios and their, yeah. Okay, and the next function we have is the studios and their average rating across all the games. And this query calculates the average rating for each developer's games. And the original CSV file had a few duplicates, so I made sure to remove any using a subquery. It's a great way to spot which studios are consistently putting out quality content, not just popular content. Okay. And one of the more complex queries we had is the query that lets you choose the range of rating you want and filter it under a certain value. I don't know about you, but I like playing a fun lasting game or a diverse game, but also not having to spend $60. So this one lets you it lets you input a range for the rating. So if I only wanted to play games rated, the rating scale is on 1 out of 5. So you could put the rating between 4 out of 5 and play some of the best rated games, and then also include a pricing filter below 50. So we did that here, and we got a great amount of games down there. Some on sale, some older games that may have gone on sales or different versions, multiple Final Fantasies, and Elden Ring's on there now. I believe that went on sale, and you can see the rating's great. I've played it. You get a lot out of that game. Okay, and the last one is the query to show how many developers are from each country. I just found it interesting. If you think about a main, very popular developer like Nintendo, we all know that's from Japan. So I would like to know how many developers are like, what countries have the most developers and are putting out the most games. So here I focused on developers from Japan, but we could also easily compare with the USA or other countries. This kind of data helps us understand where the creative hubs in the gaming industry are located. And you can see down below the results. And this was our project for the games organizer. Thank you.